frequency is 4 for the first class. The second class is 60 to 69, even though this is unit 1, but because it's unit 1, people forget about it a lot. So this is 319. For the third one is 70 to 79. And the frequency in that one is 1466. So the first thing I want to say is that whenever you're given a horizontal table, the first thing you want to do is make it vertical. Make a horizontal table verticals. Can you hear me, by the way? You can hear me, right? Hello? Okay. All right. Okay, so change the horizontal table because I know it's going to be horizontal again when I print the test or you go to the test. All right, so when you finish changing the horizontal to vertical, like I'm doing now, the 80 to 89, that's the class, the next class. And the next one is 90 to 99. And by the way, the frequency is 1481. So let's see what that frequency is, 1481. So I put 1481 there. 1481. And the next one is 90 to 99. 90 to 99. And the frequency for that is 220. And the last class is 100 to 109. 100 to 109. And the frequency is 13. So the first thing you want to do after you first thing I want to do is try and find the class midpoint. Remember, find the class midpoint. Class midpoint. And remember that class midpoint is lower bound plus upper bound divided by 2. And when you can find the first class midpoint, you actually know others. Allow me to pull my calculator up. Excuse me, I want to pull the calculator up. All right. Okay, and so the next thing I want to do is find the class midpoint for each class. So 50 plus 59 divided by 2, 50 plus 59 equals divided by 2. So by 2, I have 54.5. So I know we did this, but people forget that a lot. 54.5. Because it's been a long time, though, months ago. Okay, so that's the first thing I need. But what else do I need? What else do I need? If I know the class width, the class size, then I can complete the class midpoint. So what is the class size? The difference between the consecutive lower limits. So the difference between consecutive lower limits is 60 minus 50, that's 10. So the class width is 10. And then I'll add 10 to the class midpoint of the first class to get the class midpoint of the second class, 64 to 64.5. And I'll add in 10 because it has consecutive class, equal class width or class size. 64.5 plus 10 is 74.5. 74.5. And we keep doing that. 74.5 plus 10 is 84.5. 84.5 plus 10 is 94.5. 94.5 plus 10 is 104.5. 104.5. And that is the last one. So the next thing I want to do is go to my calculator. Go to my calculator and see, I'm going to start. Go to my start, edit, and I will clear the list. I want to use L1 and L2. So I'm going to clear the lists there because I don't want to use L3 and L4. It's not that I cannot use it. I want to make it easy for myself. All right, so after I cleared L1 and L2, what I'm going to do is put in the class midpoint. So the class midpoint is 54.5. Then I know is there are 64.5. They are greater by 10, 74.5 until I get to 104.5. 84.5, 94.5, 104.5. Well, to be on the safe side, you want to ask yourself, by the way, how many classes do I have? How many classes am I given? Because if I have 5 classes, 1, 2, 3, 4, 5, 6. So I am given 6 classes. I should have 6 class midpoints. So I should have 6 class midpoints because I have 6 classes. So do I have 6 class midpoints? I'm going to check too. 1, 2, 3, 4, 5, 6. It doesn't hurt to check all these things because really, if you miss anything now, no matter how accurate your calculation is, it's still going to be wrong. All right, so I will put in 4, enter. Why am I putting 4 there? Okay, but in the wrong place. So I'm going to delete. So I am going to L2. In L2, where frequency should be. So I put in the frequencies. 4 is the first one. 319 is the second one. 1466 is the third one. 1461 is the fourth one. 220 is the fifth one. 13 is the sixth one. Please someone mute yourself. Okay, so now I have entered the frequencies and class midpoints. The next thing I want to do is find the mean. And by the way, I'm told indirectly, I am told that it's a population. How do I know? How do I know it's a population? Because they told me to find the mean, mu. So actually it is population. They don't have to tell me it's a population. But when they told me to find the mu and population standard deviation, so I know. So I know I have to find the mean and population standard deviation. So let me go ahead. So what do we do? What are we going to do? One variable start. That's it. So we just do one variable start of this data. So I'm going to go to start, go to calc, one variable start. All right, it is one variable start. I have frequency. So the first list is the class midpoint. The class midpoint is the first list, and that's L1. The second list is frequency, which is an L2. I already put them in, but I want to tell my calculator where they are. And I'll calculate. When I calculate, I have the the mean they're looking for, even though my calculator labeled it as 79.55 and it said it's X bar. That is why you are the student, you are manipulating the calculator. You want to make sure that you put in mu. Of course, it's already there for you. So, and then you find out how many decimal places. How many decimal places are you told to round? Round to one decimal place as needed. So the mean is 79.6. I hope you agree. And I'm told to find the population standard deviation. And I have 7.4 for population standard deviation. And I'm also told to draw a frequency histogram. Draw a frequency histogram of the data, verify the distribution shift. I cannot do it on my calculator. You can do it by hand. You can do it by hand if you want, but I like to do it with my calculator. So I have 6 classes. The class width is 10, and I'm told to draw a frequency histogram of the data. So where do I go? To do a frequency histogram, I go to second, start plot, and I will select plot 1, and I'll select plot 1. I'll go to histogram and select that. Remember, the question says frequency histogram. It did not say relative frequency histogram. So since it said frequency histogram, I am going to arrow down. So when I arrow down, the L1 is class midpoint. The L2 is frequency, L2. So everything is good. Now I am going to zoom 9 for the first time. So, zoom 9. And when I try to zoom 9, see this argument, I will second quit. Then I'll zoom 9 again on the main screen. All right, remember, I'm told to draw a histogram. So since I'm told to draw a histogram, what I'm seeing here on my calculator is not a histogram, it's a bar graph. So what do I do to close the gap? A histogram is connected. So what I'm going to do is go to my Windows and tell my Windows that I have a class width of 10. How do I tell my calculator that? I'll go to Xscale. So Xscale is 10. Why? Because the class width is 10. Okay, that's enough. That's all I need to change. I could change the other things, but this is the most important thing that matters. After I change the class width, then I don't need to zoom 9 again. I do not need to zoom 9 again. I just have to graph. So when I don't zoom 9 again, I graph. It gives me a histogram. A histogram is connected. The bars are connected. So now I have a histogram. Well, they give me options. So I want to check my result with the result of the one. So I compare my answer with the answer that they gave me, the ones they gave me. I see that the answer, the match is C. Any question? I hope you know you can draw this histogram by hand. You don't really have to. If you don't remember the steps to do it by calculator, draw it by hand. Is the distribution bell-shaped? Yes. Yes, it looks like it's bell-shaped. If I superimpose a density curve on this distribution, looks. But you see, the superimposed density curve is bell-shaped. So that's bell-shaped. Yes, the frequency histogram of the data is bell-shaped. That's what I'm going to choose. The frequency histogram is bell-shaped. But I can also check it. I can also go back and do one variable start and see if the mean is equal to the median. That is the conclusive answer, though, because they can ask you, conclude your answer with mean and median. Remember, if a data is bell-shaped, the mean is equal to the median. If a data is bell-shaped, the mean is equal to the median. Okay, so what I'm going to do now is I can, if I want to, because they're not asking me that. But if I want to, I can just go to start again and do one variable start of this data. And I would want to actually be conclude that the data is bell-shaped. And what am I going to do? I'll compare the mean with the median. The mean is 79.6. Let me see what the median is. The median is 75.5. So I can conclude that actually that data is not bell-shaped, but it's approximately bell-shaped. You see, you can do a more conclusive proof when you are using the numbers, the mean and the median. Okay, you can see that the mean is greater than the median. So actually, it looks like it is skewed right from what we have from the calculator. From the calculations in my calculator, it looks a little bit skewed right, but I can say that by my eyeballing the data, it is bell-shaped, and I know that if you look at the answer will say bell-shaped also. But the more conclusive answer is all right. So according to the empirical rule, 95% of data, 95% of days in the month will be between plus or minus 2 standard deviations. So I already know the standard deviations. Let me go back and see the standard deviations. So the standard deviation is 7.4. So let me quickly find what 2 standard deviations above the mean and 2 below the mean are. So the mean is 79.6. So 79.6, and the standard deviation is 7.4, and that is 7.4 here. Okay, so for me to show that I understand the question, I can just draw a bell curve. Yeah, because if they're asking me a question about empirical rule, they assume that the data is normally distributed. That's what it means. Even though we can see that from mean and median, they're not exactly normally distributed. And so the mean is 79.6, and the standard deviation is 7.5, 7.4, 7.4. One standard deviation above the mean is 79.46 plus 7.4. And when I add them up, I will see one standard deviation above the mean is, so I'm going to clear I'm going to clear everything here. So the mean is 79.6 plus one standard deviation, 7.4. And I have, but I need 2 standard deviations above the mean. So I'm going to add another 7.4 plus 7.4 again. There are so many ways you can do it. So 2 standard deviations above the mean is 94.6. So 94.6 is on the right. 94.6. Is it 96 or 94? Let me check. Yeah, 94.6, 94.4. Okay, and I'm sharing this region. And there's another region on the left-hand side because I'm asked plus or minus. And then I will subtract 2 standard deviations from the mean. So I will do it together now. So 79.6 minus, this time I'm doing them together, minus 2 times. I can actually close parentheses there. Okay, I'm multiplying standard deviation by 2 because I'm doing it together. So I would know what it is. So 7.4, 2 times 7.4. And then my answer is 64.8. So this boundary here is 64.8. So according to empirical rule, 95% of data lie between 64.8 and 94.4. According to empirical rule, 95% 0.95% of the data lie between 2 standard deviations below the mean and 2 standard deviations above the mean. I hope you still remember this, but just know it is in the test. No, you must have known how I do it. I will actually just repeat the question, most of the question in the test. So anyway, so this is one of the mostly failed question in the final exam because it was done in unit 1, so people have forgotten. So you don't blame them. People have forgotten, but it takes, you can read. You see, I give you almost 2 days to take final exam. This means that you have enough time, even if you forgot. There are only 15 questions, by the way, in that test for 90 minutes. So a lot of time. That's so we don't fail your final exam. So what you do is, even if you don't know it, you come back and study. So let's look at number 8. I want you to know that this final exam is comprehensive from chapters 1 to 10. So what you do is, make sure that any question you want to answer, you know it very well. If I were you, I'll start from the ones I know. There are some easy questions here, by the way. Do the ones you know first and go back and do the others. Okay, by the way, let's go to number 8. All right, it says simple random sample of size n equal to 47 is obtained from a population that is skewed left. The population is skewed left, right? The mean is 50 and the standard deviation is 2. Does the population need to be normally distributed for the sampling distribution of mean? This is central limit theorem. To be approximated normally distributed. Yes. Skewed left does not really matter because you remember the definition of central limit theorem. Central limit theorem says that it does not matter if the original data is skewed left or skewed right or normally distributed. The mean distribution or the distribution of means or sampling distribution, they are called so many names, mean distribution, sampling distribution, central theorem, they are all the same. Anyway, so you can still do central limit theorem. It doesn't matter if it is skewed left, because those who didn't pay attention in class last semester said no, it cannot be because it's not normally distributed. So as soon as I see that, it means that the person never paid attention. That's all. Because central limit theorem says it doesn't matter whether the original data is skewed left or skewed right or normally distributed. So you really want to make sure that you know that part of the definition. Okay, so now that we have reminded ourselves of definition of central limit theorem or the mean distribution, we can answer the question. So let's answer the question. So what you want to do is they will always ask you to find the explain the distribution of the means. Yeah, so does the population need to be normally distributed for the sampling distribution X bar to be approximately normal? No, it does not need. That's this question I was answering. It does not need to be normally distributed because central limit theorem already said that it does not. Okay, so you make sure you choose an answer that says it does not need to be normally distributed. Now, they continue to ask you questions, which means they already know. They already know that it doesn't have to be normally distributed. So the question number question B, what is the sampling distribution of X bar? So whenever you are asked about sampling distribution of X bar, it means that they are asking you to find the mu X bar, the mean of the central limit theorem, and standard deviation of the central limit theorem. Remember, the standard deviation of central limit theorem is called standard error. So that is standard error. And actually, you can find that standard error by standard deviation of the original data divided by square root of sample size. So I want to make sure you know this. Also, the mean of the original data is equal to the mean of the central limit theorem. But the standard error is not the same. So let's go ahead and figure them out now. So let's go back and get so we found that the mean of the central limit, or the original data is 50. So mu X bar is equal to the mean of the original data, equal to 50. Remember, I don't have to put two equal signs. I'm just trying to make sure. So the mu X bar is 50. The mean of the original data is 50. All right. So the next one is, what is the standard error? You calculate that. Find the standard error. The standard error is standard deviation of the original data, which is 2 divided by square root of sample size. So what is the sample size? Sample size is 47. So you get your calculator and simplify that. So I am going to get my calculator and find the standard error. That is 2 divided by square root of 47 divided by square root of 47. And what is that? What's my answer? Whatever my answer is standard error. So the standard error is 0.29. By the way, they will tell you to leave your answer to some decimal places. So what is the decimal? Approximate your answer. See. Okay. Let me see how many decimal places. Round to 3 decimal places. Okay. So my answer to 3 decimal places is 0.292. Therefore, the standard error is 0.292. So you just put in the sampling distribution of the mean is 50 right here. And you make sure you look at the 1 points, put whatever your answer is here. Okay, so that's number 8. Let me see if they asked us more questions here. Number 8, is that it? Okay, so I hope everybody knows how to find the linear regression, okay? Interpret the slope and y-intercept. The first thing you want to do is the predictor variable, or x, is L1, response variable is L2. And then let me get my calculator, but I'm not doing all of them. That way, so I am going to put the data in my L1 and L2. So go to Start, and I'm going to clear L1. So see, the first 2 questions we're answering are from They are from Unit 1 and Unit 2. So the first is 5, enter 15, 25, 40, 60, 72, 105. Okay. And the L2 is 69.1. So this is the response variable. Why? So 69.1, 68.1, 67.1, actually 7.2, and 66.3, 65.1, 62, 65.2 again, 0.2, and 62.5. 62.5. Well, immediately I finish putting them, people make mistakes. So I want to glance at my data. Did I just make an obvious mistake? I could have typed in a 4-digit number, you see? So it looks like I did type in something good. All right. Now I want to do a scatter plot. First thing I want to do is to draw a scatter plot. Okay. So to draw a scatter plot, I go to second star plot. This is from Unit 2. We already told you that final exam is comprehensive. It is a standalone exam, and it will replace one low test grade. Don't forget to take, I hope they did take extra credit. It closed yesterday, though. Extra credit closed yesterday. Okay. Anyway, so I am here now. I need to do one variable stat. So let me first of all go to make sure that my data is okay. All right. So I am actually somewhere the other way around. I am supposed to go to linear regression. We all know that linear regression, there are two of them. That's one in 4, and that's one in 8. One in 4 and one in 8. So I like to select number 4. All right. L1 and L2. Okay. So L1 is my predictor variable. L2 is response variable. Frequency, I don't have frequency. I delete that. I make sure I delete that because I don't have frequency. And it's asking me right there, what do you want to put your equation in any of the functions? Yes. Remember this. So how do you tell your calculator that you want to put the equation in y1 or y2? It's vars, y vars, function y1, vars y vars, function y1. Well, people do forget that. Is there any question? So don't forget to tell your calculator where to put the equation. And before I click, I actually want to make sure that I have 3 decimal places. I like that. I want my number of decimal places to be 3. So let me check. Okay. I can do it now and check it, maybe go over and repeat the other step. So I want to tell my calculator that I need only 3 decimal places. And I want to turn diagnostic on also. So I go to diagnostic on. If I click alpha, I can go ahead and look for diagnostic on. And when I get to D, All right, second quit. All right, so I want to turn diagnostic on. So you can quickly go to catalog, and then if I go to D right here, if I go to D, I know I am in D. Then I can start looking for diagnostic on. Yes, I'm on diagnostic on. Then it's asking me, what do you want to do? I'll turn it on. Okay, so the reason why I turned it on is because I want to have my coefficient of correlation and coefficient of determination. All right, so now I want to go back to start and populate my one variable start. Well, linear regression. So pull down linear regression. L1 is where it's supposed to be. Predictor in L1, response in L2, no frequency. I want to tell my calculator again that I want my questions in Y1. So vars, Y vars, function Y1, and calculate. Okay, so this is my, this is actually my, everything that I need to know. They told me the kind of equation I have, the kind of linear equation I have, and they told me that A is the slope and B is the y-intercept. Okay, so I can actually write it down here. So you can say, alternatively, you go to y equals, and you see that equation. You see the equation in Y1. But you know what I'm going to do? I am actually going to zoom 9 again. Zoom 9. When I zoom 9, I forgot that I did not clean that. Okay. So what I'm going to do, I will have to go back and zoom 9, because the reason why I want to zoom 9 is I need to see how does it look? How does it actually look? So I am going to make sure I got scatter plot. I'm zoom 9, scatter plot. The reason why I want to see it is so that I will know how the scatter plot looks. How does it look? This line is the line of best fit, which I put in Y1, so it's still okay. So, but the scatter plot is, if I look at it, how did you know that it's rising to the left? So it has a negative slope. No wonder the slope is negative. And whenever the slope is negative, the coefficient of correlation is also negative. The slope is negative, the coefficient of correlation is negative whenever. All right. Okay, and I can actually, if I want to, I can actually go back and do this. It doesn't have to do it again, so that you see everything that you needed. So I'm doing it again. I want L2, no frequency, and vars. You want to y vars, function y1. I hope saying it a lot of times will remind you. Okay, and now I'm going to calculate. This time I will know whatever I need. The coefficient of determination, the coefficient of determination, I don't know if they asked me to find it, but it doesn't hurt to know all that I'm given. All right. So that equation says that y equal to, remember that this is predicted. This is the predicted equation. And the predicted equation says that negative 0.061 x. And then the y-intercept says 69.041. Okay. Now interpret the slope. See, because slope is negative. I better know that, but that slope is negative. Look at that, everybody. So the slope is negative. So it means as x is increasing, y is decreasing. So for any increment of y for 1, x is decreasing. So x there, one is increasing, the other one is decreasing. And any other way you know how to interpret the slope. Remember, you can also use this and say that since this line is this way, as the horizontal is increasing, this is increase and increase, you see, the vertical is decreasing. The vertical is decreasing. You can show that. You don't really have to, but if you have to show that, you show as the horizontal is increasing, the vertical is decreasing. And the vertical is the response variable, and horizontal is explanatory variable. Okay. And I said I wouldn't do that, but I did it. Okay. Let's spoon fit in, because that means I give you the predict the well-being of the you have to answer all that. But I just want to remind you how to find residual. The question says find the residual. Remember that residual is observed minus predicted. Observed minus predicted. For example, if I'm told to find one residual here, let me go to, if I'm told to find a residual for 40, the observed for 40 is 66 residual. Residual. All right, so it's the same as the observed. What is my observed? 66.3, 66.3 minus the predicted. And what do I mean by predicted? See how you can find predicted. F of 40 minus F of 40. And what does that mean? It means go to that equation in y1. Go to that equation in y1. You can say y1, what is it? Verse y verse function y1, and then substitute 40 in that equation. F of 40. And that is 66.601. All right, so what I'm going to do now, I will put this in my X. So I stored the predicted in my X. Then the observed, I already know, is 66.3. 66.3 minus the quantity in X, and that is negative 0.301. So the residual, the error, some books call it error. The residual is negative 301. What does it mean? It means that this point is not on the line, it's actually below the line. How do I know it's below the line? Because it's negative. Whenever the residual is negative, it's below the line. When the residual is positive, it's above the line. And you could be told to find the residual for all of them. You can do them one by one. You find the residual for this, you keep it and find the residual for this. You can do that one by one and add all of them. That's another method you can use and do all of them, but I find out that it confuses students. So I stopped showing them how to use it. So what I want to do is, like you find the residual for 40, you can find residual for, and how do you do that? You can just say, I'll bring down the equation in y1, verse y verse function y1. You already know. The first thing, if I were you, what I'm going to do is put the value of the observed for that. Remember, observed for 5 is different. Observed for 5 is 69.1. Observed for 15 is 68.1. So you have to take your time and do them one by one. And by the way, if the question is too long, I already told you that. If the question is too long and it's going to take you more than 30 minutes to do, go ahead and do all the other questions you know how to do. and then come back to the one that takes you a lot of time. But let me see. They will ask you to find the observed, find the residual. They might ask you to find one residual, or they actually ask you to find the sum of square residuals. The sum of square residuals is the residual for all of them. 1 plus this, plus this, plus this. Sum of the square residuals is add all the residuals for all the inputs. Yeah, if you know how to do one, you can do them one by one and get them. Alternatively, you can put it in your calculator. I can show you that one, but whenever you people keep getting confused, so I just leave you to do it the way you want to. Okay, determine if the distribution is discrete. Whenever if you're told to determine if it's discrete, you want to make sure that the sum of the probability is equal to 1, and there is no negative probability. This is an easy question. And the question so far, I don't really think I need to do all of them. Trust me, I'm not trying to spoon feed, because we have actually done a lot of them. We did the hypothesis testing. We just did it the other day. We did the confidence interval. Remember how to calculate combinations. If you use your calculator, that is going to be good. Remember how to find